Now, let us move to next illustration. In this illustration, monoatomic gas is taken and this is undergoing the cyclic process, and this cyclic process consists of two isothermal, this is BC and DA, and two isobarics, that is AB and CD. During the cyclic process, minimum and maximum temperatures are given. Minimum temperature is 400 Kelvin, that means this process should have the temperature 400 Kelvin and this process should have the temperature 800 Kelvin. The ratio of the maximum to minimum volume is 4, that means if this point is having the minimum volume V naught and maximum volume should corresponding to point A, this should be equal to 4 V naught. And here we need to calculate the efficiency of the cycle. We know efficiency is the W total divided by Q in, and this is the PV diagram. But in this PV diagram, we cannot calculate the area enclosed. That means we need to calculate the work done by each and every process, then finally sum all the work done. And similarly, we need to calculate the value of Q which is positive, do the summation of all positive value of Q. Then finally, we put all values of W divided by Q in the formula of the efficiency for calculating the efficiency either in the ratio form or in the percentage form. Okay. So, let us move one by one, and we know this is having the 400 and this is the 800. If we consider this process, we can observe the pressure is not changing. That means this process, that is the AB process, is isobaric process, right? And we know ideal gas equation PV equal to nRT, right? If P is constant, V is proportional to T. If V is proportional to T, we know the volume is this point, volume at this point is 4 V naught, and temperature, we know temperature become half while moving from A to B. That means volume at this point should also be half. That means volume at point B should be equal to 2 V naught. So, let us find the volume here. This volume is 2 V naught, right? Now, let us calculate the work done. For isobaric process, calculating work done is easiest one. Now, here we can write pressure multiplied by change in the volume, right? We know this is equal to 2 V naught. So, this is the final expression for calculating work done in the AB process, and at position V, this is 2 V naught, and position A, we have the 4 V naught, but we do not know the value of P, right? But here if we multiply P in this equation, we will have the value of P VB minus P VA, correct? And from ideal gas equation, we can write nRTB minus nRTA. Okay, if we take nR common, this value is equal to TB minus TA. So, we calculated the work done in AB process. We know the value of TB, we know the value of TA, that is 400 minus 800, and this is equal to nR multiplied by minus 400, and this equal to minus 400 nR. So, work done here is negative. Let us explore the value of Q is positive or negative. That means heat is either absorbed or rejected. We know this is the isobaric process, and in the isobaric process we have the expression QAB equal to N Cp delta T, right? Delta T means final temperature minus initial temperature, and we know temperature TB is less than TA. That means this value is going to be negative. If this value is negative, that means the heat value associated with this process is negative, and it is if it is negative, that means heat is extracted or heat is rejected. That means in calculating the efficiency, we need not to use this value, okay, but W value we need to add individually. Now, let us move to next process. Next process is the BC process, and we know BC process is the isothermal process. We know the first law of thermodynamics, we have Q equal to delta U plus W, and for this process delta U equal to 0, that is Q equal to W. And for calculating the value of Q, we have the direct formula, and this formula is WBC is equal to NR T multiplication natural log final volume divided by initial volume. Final volume is the volume at point C and initial volume is volume at point B. Okay. And here we know the volume is V naught, here is 2 V naught. So, this is NR multiplication 400 multiplication natural log V naught divided by 2 V naught. And after solving, we can write this expression as minus 400 NR natural log 2, right. That means we have calculated also heat associated with this process, because we know in isothermal process W equal to Q. So, heat is extracted, and if we want to calculate this value, this should be equal to this much. Now, let us move to next process from C to D. C to D is the isobaric process, because pressure is constant over this process, and we know the temperature, final temperature is greater than the initial temperature, and for this process let us calculate the volume of this point, right, because we know this PV equal to nRT, and here P is constant, this value is constant, that means V proportional to T, and if V proportional to T and volume at this position is V naught and temperature is 400 Kelvin, temperature at this position become 800, that means volume should also be double, that is 2 V naught, right. So, we can write this volume, that is the volume at point D equal to 2 V naught. So, we got the volume at this position. Now, we can calculate the work done in this process by using the simple formula WCD equal to P final volume minus initial volume, right. And we know the final volume, we know the initial volume. This is equal to P multiplication VD. This is equal to P multiplication, this is 2 V naught minus this V naught. But we do not know the value of P. So, here we can write P multiplied by 2 V naught minus P multiplication V naught, and this can be written as NR multiplication this temperature TD minus NR this temperature, this is TC. So, here we can write NR TD minus TC. Okay. So, we can write now this expression. Now, we can substitute the value for calculating the work done. This is final calculation will be equal to NR 400, or you can write 400 NR, right. Now, let us find the value of QCD. This is the isobaric process. Isobaric process, we can write Q equal to N Cp delta T, right. And as we know, TD is greater than TC, that means this value will be positive, and this is a value Cp is equal to 5 by 2 R. So, this is N multiplied by 5 by 2 R multiplied by this is 800 minus 400, that is equal to 400, right. That means this is going to be positive, that means heat is absorbed, and value of heat equal to this will be equal to 200, and 200 multiplied by 5 equal to 1000 NR. So, heat is absorbed in this process, and this is 1000 NR. Now, let us move to the final process, that is DA process. We know DA process is again isothermal process, and isothermal process, as we done in the BC process, we will repeat for this process also. We can write the formula, right, and we know the temperature, we know the initial volume, we know the final volume both. Now, we can substitute this value, this is equal to VA equal to 4 VA V naught, and this equal to 2 V naught, and this is equal to 800, right. Now, after solving, we will have this value, this is 800 NR natural log 2, right. And because this is the isothermal process, and first law of thermodynamics allow us, because delta U equal to 0 for isothermal process, that means W equal to Q, that means Q value for D2A is equal to WdA, that is equal to 800 Nr natural log 2. That means heat is absorbed by the system in this process. Now, the final calculation, let us substitute the value of W total and Q in, right. So, we have calculated here W AB, right, and this value we need not to write, and here W BC we need to write, and Q value we need not to use because it is negative, and here WCD we need not to substitute, and value of QCD is also useful for us for calculation, and we need to use this value also. So, we can write this, right, and further calculation allow us to solve like this, and final value will be this much. Okay. If we multiply this expression by 100, we can write the efficiency in the form of percentage. Even you can take common 2 here and common 2. So, it is 2 natural log 2 divided by 5 plus 4 natural log 2 multiplied by 100. This is the efficiency. Now, let us move to next illustration. In this illustration, a fixed mass of the gas is taken through process A, B, C and A. AB is isobaric. This is isobaric process. BC is adiabatic process, and CA is isothermal process. Okay, we need to find the efficiency of the process, and here we are given gamma equal to 1.5. Okay, if we analyze this diagram, we know the volume and pressure at position A, volume and pressure at position B, but we don't know the volume and pressure at position C. But we know this BC is an adiabatic process, right, and this CA is isothermal process. Adiabatic process, we know PV to the power gamma equal to constant, and adiabatic process in isothermal process PV equal to constant. We know the equation of the process for this part and this part. That means, we will use these two equations to find the volume and pressure at this position. So, let us first take BC process. This is adiabatic. We can write here PB VB to the power gamma equal to PC VC to the power gamma. Gamma is the adiabatic constant. Let this equation number 1. Now, CA, this is isothermal process, and as we discussed, PV equal to constant, that means PC VC equal to PA and VA. Right, this equation number 2. Now, if you consider this equation, if you take this equation, we can write this as PC multiplication VC and multiplication VC to the power gamma minus 1, because this combined will be equal to VC to the power gamma. So, let us write this part from equation number 1 like this. Okay, but you can observe here this PCVC value, PCVC equal to PAVA. That means, in place of PCVC we can write PAVA, right, and here you know the pressure at position A and pressure at position B is same. That means, this and this value will get cancelled. That means, we can find the unknown value, that is the VC value, from this equation. Now, we can write this VC to the power gamma minus 1, this is equal to VB to the power gamma divided by VA, right. That means, VC can be written as this value overall power 1 divided by gamma minus 1, right, and we know this value is equal to 1.5, that is 3 by 2. So, this is equal to VB to the power 3 by 2, and this is 1 divided by 3 by 2 minus 1, that is 1 by 2, and this value will be equal to 2. So, we can substitute the value of this as 2 and this is 3 by 2, and VB here is 4 V naught 4 V and VA equal to V. That means, we can write this value as this will be equal to 64, and this is square, this will be V cube divided by V square, right. Now, this and this will get cancelled, that is equal to 64 V. Now, we can substitute this value V c here to get the value of the volume, right. So, here we can write P c equal to P A V A divided by V c, right, and V c equal to this value. So, this pressure will be equal to P divided by 64. That means, we got the pressure and volume at this position, right. Now, let us move to calculate the burden and heat associated with each and every process. Let us write this value pressure and volume at this position. Let us start moving from A to B. A to B is isobaric process, and for the isobaric process we can write heat equal to Q equal to N Cp delta T. Delta T means Tb minus Ta, right, and we know the value, this Cp equal to gamma R divided by gamma minus 1, and this is Tb minus Ta, and N is the number of the moles, okay. And this value we know, this is equal to, we can further write this value as 3 by 2 multiplication R, because gamma equal to 3 by 2 1.5, and this is 3 by 2 minus 1. We can further rearrange this equation and we can write this QAB equal to N multiplied by, this is 3 R multiplication Tb minus Ta, right. And if we multiply this value with the N and R, so this will become, this is 3 multiplication P, this is Vb minus Va, right. We are using the ideal gas equation here, and this is value 9 PV. That is the heat associated with this process is 9 PV. This value is positive, that means Q in this process. So, we got this value, right. Now, we can write the value of the burden, WAB equal to P multiplied by delta V, and P is value pressure P and delta V is 4 V minus V, and this is equal to P multiplied by 3 V, that is equal to 3 PV. Okay, we got the value of WAB and we got the value QAB. Now, let us move to this process B to C. B to C is adiabatic process, and for adiabatic process we have the ready-made formula for calculating burden. We know the burden in adiabatic process is P initial V initial minus P final minus P final multiplication V final divided by gamma minus 1. So, in the same fashion we can write the burden for this process, this one, right, and we know gamma equal to 3 by 2, and PC and VC we have calculated already, this and this we have written also. So, we can substitute these value, this is P multiplication 4V and this is P divided by 64 and this is 64V and this is 3 by 2 minus 1. Right, and this 64 and 64 will get cancelled, and after solving we will get this value 6 PV, that is WBC equal to 6 PV. Okay. Now, let us move to this process, because it is the adiabatic process, that means Q equal to 0, we need not to calculate this value Q. Now, let us move to this process. Here you can observe the volume is decreasing, that means burden will be negative, and this is the isothermal process, and we have the first law of thermodynamics, Q equal to delta U plus W, and delta U equal to 0, and if this is negative and Q is also negative, that means Q will be negative in this process, but we need to calculate W for calculating the efficiency. So, we can use the formula, that is a direct formula, W CA equal to nRT natural log VA divided by VC. Now, we can substitute the value nRT equal to PV, and this is equal to 1 divided by 64, because we know the ratio. So, this can be written as this one, and this is 2 to the power 6, and if we move to a numerator part, this is 2 to the power minus 6, right, and this is equal to minus 6 PV natural log 2. Now, we calculated the burden and value of Q where it is positive. So, we can substitute in this formula efficiency equal to W divided by Q in, and W we will add individually, and Q in is only the one process where it is positive, that is AB, this value, right. So, we can write this is 3 PV first process, AB 3 PV plus second process, this is BC, this is 6 PV, and third process it is minus 6 PV natural log 2 and divided by Q in, and Q in is only in this process which is positive, that is 9 PV, and PV will get cancelled, and this on solving will have this value, that is 3 minus 2 natural log 2 divided by 3 percentage.